Hello students, so this is the latest worksheet that I gave you for revision. You should have already tried it, so let us now compare our solutions and hopefully you have been successful. If not, do your corrections, revise this to be in preparation for your class test, alright? Right, here we go. First one, find the value of p squared plus 4q when p is negative 1 and q is negative 2. And of course, a denominator p cubed and times q. So what we're going to do is when we substitute a value in, like p and q, just a reminder, it's a good habit to actually put them in parentheses or brackets. So that's how I would write out my solution. Okay, so I have my p squared plus 4q over pq, right? I'll replace my p with negative 1, right? Plus 4, replace my q with 2. In the denominator, again, replace my p with negative 1. Notice when I put negative number, always have the parentheses or the bracket around it. Times my q is 2, right? So when you do this, it's really important to have the brackets. If not, bad things will happen, right? So from here, you work this one out. This is going to be 1 plus 8 over negative 1 times 2, right? And continue to simplify. This will give us negative 9 over 2. You can of course write it as a mixed number if you prefer that. Looks neater. Okay, so that's the first one. Part B, again, this time round, algebra, but what we are dealing with here is actually testing and making use the application of the algebraic identity, right? So what we can do is we start with x plus y, okay, is equals to 6. So x plus y is equals to 6. Now what happened is, okay, if I were to square this, I will end up with 6 squared, right? So that means expanding this, x squared plus 2xy plus y squared is equals to 36. Now x squared plus y squared is 30, so 30 plus 2xy is equals to 36. So 2xy is going to be equals to 36 minus 36. Xy is equals to 3. So that's part B, successful. Now part C, what are we dealing with now? Okay, this time round there's some fractions. So we have x over 3 equals to 1 over 3 minus 3x minus 1 over 2. What we can do is to actually make the denominator common. So in this case, I can make the denominator 6. So 2x over 6 equals to 2 over 6 minus 9, right? Multiply by 3 on in top and below, 3 over 6. So 2x equals to 2 minus 9, x minus 1, right? I multiply by 6 throughout, okay? So this gives me 2x equals to 2 minus 9 plus, oops, let's revert back, minus 9x plus 9. So 11x equals to 11, x equals to 1. There we go. Okay, moving on, next question. Question 2, find this value again. What we do again, substitution, another practice. So here we have a is 8, put it in nice little parentheses, minus b is negative 2 square over, right, again 8 minus negative 2 cube. Okay, so this gives us 8 minus 4 over 8 minus negative 8, right, resulting in 4 over 16, simplest form, 1 over 4. Okay, right, next. Question 3a. The resolution is a bit bad. Oh well, I'm sure you can still read it. So we're supposed to expand this. So expanding this, part A, 2a plus 5 squared is actually 2a squared plus 2a 5 plus 5 squared. Simplifying this, 4a squared plus 2 times 2 times 5 gives us 20. 20a plus 25. There we go. Part B. Hence, by using a suitable substitution, calculate the value of 205 squared without the use of calculator. So what happened? 205 squared is actually the same as 200 plus 5 squared, which is the same as 2 times of 100 plus 5 squared. Okay, so by comparing, we let, okay, a is actually equals to 100, right? You can see that over here. This is a. Okay, so what we can do is, therefore, okay, 205 squared is actually, just use the expanded form, 4 times 100 squared plus 20 times 100 plus 25. Okay, this works out to 42025, right? This is 40,000 plus 2,000 plus 25. Okay, next question. Factorize fully. Okay, so let's go. First one, 2x cubed y minus 8xy squared. What we're going to do is, first we're going to identify the common factor, extract them out. So 2xy is common. I will end up with x squared here, right, minus 4y, right? Now, after this, what happened? Well, is it the simplest form? It's the simplest form, right? We can't do anything because 4y is not a perfect square. So that's the simplest form. We're done. Part B. Well, part B, we have 6a squared plus a minus 15. Okay, if you are familiar with the cross method, this will give us the, let me see, let's do a simple sketch. Let's do a simple sketch. Okay, so top left hand corner, 6a squared, bottom right, negative 15. I want to obtain a. So I can try a few different combo. A good combo will be 2a, 3a, right? So 2a, 3a means over here I will have negative 3 and 5. Yeah, that works, right? So this will be negative 15a. Sorry, negative 15 over here. Rewind. Don't mind me, all right? I'm just trying to sort this one out. So I want a on these two, right? So I have 2a, I have negative 3 here, which gives us, this one is negative 9a, right? If I plug in 5 here, right, this will give us 10a, right? So 10a minus 9a gives us a. So this is good. So this will end up with 2a minus 3 times 3a plus 5. Okay, this is positive 5. There we go. Okay. Of course, you can use the cross method if you prefer that. Nothing wrong with that. But we have done this many times in class, so I'm confident that most of you will be able to do this. Now, the third one, okay, this is where we need to use grouping, right? So let's copy out the question. Okay, so by grouping, the first two terms we have 7. Yes, 7 is common. P is common, right? And is anything else? No. So I end up with Q minus 2P. Okay. On this side, okay, let's see. If I take out 3 is common. So maybe I just put plus first. It doesn't matter. 3. Okay. What else? A is common. Okay. So I end up with negative 2P plus Q. Right. Now, negative 2P plus Q and Q minus 2P, they are the same thing, right? So we'll end up with Q minus 2P, and then we have 7P plus 3A. There we go. That works. Okay. Moving on. Next question. Oops. What happened to my scrolling? There we go. Okay, this is another expansion identity question. So this time round, the value that they give us started out is a bit different. But we're still going to start from here, right? A plus B squared is 1, 2, 3. Right? So this means A squared plus 2AB plus B squared is equals to 1, 2, 3. Oops. 3. So A squared plus B squared is 25. So 2AB equals to 1, 2, 3 minus 25. So 2AB equals to, that's my calculator, 98. So AB equals to 49. Therefore, square root of AB equals to 7. Okay, moving on. More fractions. Okay, we can do this, no problem. Let's see. Solve the first one. We go 1/4 equals to 1 minus x over 2 minus x over 3. Okay, we can make the denominator common. Common denominator, I can make it 12. So this will be 3 over 12 equals to 6, 1 minus x over 12 minus 4x over 12. All good? So all the denominator are common. That means 3 multiplied by 12 throughout, 3 equals to 6, 1 minus x minus 4x. Simplify this, we have 6 minus 6x minus 4x. So 10x equals to 3, x equals to 3 over 10. There we go. Okay, part B, given that x plus y, okay, well, this one is interesting. We this time round we start with the x squared. Let me label it as part B first. We start with x squared minus y squared equals 21, right? So this gives us x plus y, x minus y equals to 21. That means x plus y is 7, so 7 times x minus y equals to 21. That means x minus y is equals to 3. Now, what happened is from here, we know that x, there are a few ways to do this, right? Let me show you another way. We have x plus y is equals to 7. Okay, so what happened is if I take the, okay, this equation 1, equation 2, if I just subtract them, right? So x minus x is 0, negative y minus y, this will be negative 2y equals to negative 4. Hello? Negative 4, y is actually equals to 2. That's one way to do it. Okay, so what happened? From here, we call it 3. We take this, we put it back here, right? So we have x plus 2 equals to 7. Therefore, x is equals to 5. Right? So therefore, xy equals to 5 times 2 equals to 10. Well, that's one way to do it. Of course, there's another way. We have already seen it, okay, in our previous revision. Okay, continuing. Now to the inequalities. Let's solve the inequalities here. So part A, 3x minus 5 is less than 3. So 3x is less than 8. X is less than 2 and 2/3, right? So the list of integer, well, this time round it will be integer 2, right? So both. So we need to solve the other one. Let's go. Part B, 1 minus x over 2 is less than or equals to 2. 1 minus x is less than or equals to 4. Then we got negative x less than or equals to 3. So x is greater or equals to negative 3. Okay, so if you look at the number line, we go from negative 3. Okay, and then this is 2 and 2/3. Okay, therefore, oops, let me try to do it nicely, right? Therefore, okay, list of integer. Let's spell it properly. Integer is, we have start from negative 3, negative 2, negative 1, 0, 1, 2. There we go. Okay, right, continuing. Okay, this another inequality to solve. So x plus 3, part A, is greater or equals to 3x over 2 plus 2, right? So let's multiply everything by 2. We can do that. So 2x plus 6 is greater or equals to 3x plus 4. That means negative x is greater or equals to negative 2. X is, oops, we got to change the direction. 2. That's equals 2. Let me check. 4. Did I Miss out something? Nah, looks good, right? Okay, so hence write down all the, yeah, okay, no, the reason why I hesitated is because I'm looking at the solution done by someone else on the same question, and it seems that there is a mistake over there, right? But we are good. Okay, so hence write down all the positive integer, right? So all the positive integer will include 0 is not positive, 1, it can be 2. There you go, it's just 1 and 2. Okay, right, moving on. Next one. Okay, given that these two values are there, what's the smallest possible of x squared y? So go smallest possible value of x squared y is equals to, well, we want the smallest x squared. Smallest x squared, in this case, we will have negative 2 squared, and then we will have the smallest value of y times 1, right? Which will give us 4. Is that the smallest possible? Yeah, that's the smallest possible. Okay, then we want the largest possible of, let's go, largest possible value of y plus 1 over x. So now we want the largest y. The largest y is 5. So we have 5 plus the largest 1 over x. The largest 1 over x is going to be 1 over negative 4, right? So we will actually subtract by 1/4. If we put negative 2, it will actually subtract by half, which will end up with a smaller value. Okay, so this will be 5 minus a quarter, which is 4 3/4. Right? Okay, so let's move on. Next one, Mary is drawing a triangle. The first angle is x, the second angle is 18 smaller than the first angle, and the third is 4 times. So what we can do is we add the 3 angles together. X plus x minus 18 plus 4 times, right? 4 times the second angle. So we have this, and the sum is actually 180. Okay, so we work this one out. We have x plus x minus 18 plus 4x minus 4 times 18. Where's my calculator? 4 times 18, 72 equals to 180. 6x is equals to 180 minus 180 plus 72 plus 18 is 270, right? So x is equals to 45. Okay, right? So the smallest angle is equals to, the smallest angle will be x minus 18, which gives us 27 degrees. Okay, done. Next go. Okay, find the size of each exterior angle of regular heptagon. So heptagon has 7 sides. Therefore, okay, part A, size of each exterior angle, in this case, will be 360 divided by 7. So, and that will give us 51 3/7 degrees. Okay, so that we find. Now, part B, one of the interior angle of an octagon. Octagon is 8-sided, is 149. The remainder are equal in size. Find the size of the remainder. So we can, what happen is let remaining interior, come on, it's my Apple Pencil date, interior angle be x degree, right? So 149 plus 7x equals to, well, 8-sided, right? So 180 times 8 minus 2. So we have, work this one out. 149 plus 7x equals to 6. 6 times 180 is 1080. 7x is equals to, that's minus 149, 931. Okay, divided by 7. X is equals to 133, right? So therefore, therefore x degree is 133 degrees units. Okay, right, that's the last question I asked you to try. So I hope you have been successful. If not, do your corrections and try to understand how this whole thing works. Okay, do come and look for me if you need more help, and keep practicing more questions from your assessment books, from your textbook, from your workbook in preparation for your test.